All right, in this video, we're going to talk about the relationship between the sample size and the sampling distribution. So this chapter has been very conceptual, and I think sometimes in stats it is important to step back and think about things just logically, because I'm throwing a lot of formulas at you, a lot of numbers, and I know it's overwhelming, but sometimes it's good just to stop and think about conceptually, does this make sense? Why are things the way that they are? So I think this is a good example in this video. So let's look at the sample size, what happens as it increases, how it affects the standard error. So remember, the standard error is the standard deviation for the sampling distribution. So it's a standard deviation, so a standard deviation is a measure of dispersion. So intuitively, it should make sense that as our sample size increases, where we have more information, we have less room for error, so of course our error should decrease. Our variability in our data should decrease. So conceptually, that's what's going on. Mathematically, we can talk about it. So we can actually plug in some numbers and show an example. So we want to know what happens to the standard error, right? This is our standard error, standard deviation for the sampling distribution of X bar. What happens as the sample size increases? So let's take the population standard deviation, and let's just keep that constant at 10. So we have two different scenarios here. We have one when our sample size is, 100, and another when the sample size is equal to 400. So in our first situation here, we have 10 divided by the square root of 10, right? By 100, 10 divided by 10 is 1. So in this first scenario, our standard error is 1. In our second situation, we have 10, right? We're keeping that a constant, divided by now the square root of 400 is equal to 10 divided by 20, which is 0.5. So mathematically, we've just shown that what happens as n increases from a sample size of 100 to 400, our standard error decreases. So sometimes if you're not sure about stuff, you can test things out. You can do stuff like this. So mathematically, we've just shown that, hey, as your sample size increases, the standard error, right, it decreases. But again, we can think about it conceptually, right? So if your sample size is getting larger, you have more information, you have less error, so it makes sense that your standard error decreases, right? Your standard deviation or your variability of your data is going to go down. The values of X bar have less variation and tend to be closer to the population mean. So this is an important sentence. It has important implications, because if now we're saying there's less variation and the values tend to be closer to the population mean, right, this is affecting our distribution, right, our sampling distribution. And remember, that's going to affect the probabilities that we calculate. So larger sample sizes provide a higher probability that the sample mean is within a certain distance of the population mean. So I think that we need to take a step back and realize, because I don't know if this is coming through as clear or not, is that sampling distributions are different depending on sample size, right? Because remember, for your sampling distribution, right, it's standard error, its standard deviation for the sampling distribution, depends on the sample size. So if your sample size is larger, right, you're going to have a larger sample size, your standard error is going to be smaller, right? So think about that as the big picture too, that you're going to have different sampling distributions depending on the sample size that you use. So, right, in terms of thinking about, okay, if I want to know, right, remember, ultimately we want to know, right, the probability that the sample mean that we calculated is within a certain distance of the population mean. Well, basically, if you want to have a higher degree of certainty that your sample mean is closer to the true population parameter that you're interested in, one thing you can do is collect more data. Have a larger sample size, because by having a larger sample size, you have a smaller error, and what happens there is that you have a higher probability that the sample mean will be within a certain distance of the population mean. So again, conceptually thinking about these ideas, I know sometimes it's easy just to plug in values into an equation, but sometimes it's good to think about what you're doing, why you're doing it, and how it's related to the big picture of statistics and understanding probability.